Imagine a comet, traveling through the silent, cold darkness of the galaxy for millions of years. Untouched, unseen, and unknown, a lonely wanderer drifting between stars. Until now. Because in 2025, astronomers noticed something absolutely shocking. The interstellar comet 3ITLAS suddenly started brightening, way faster than anyone expected. Why? What could have possibly changed? Is this just a normal cosmic process, or are we witnessing something we have never seen before? Today, we're breaking down the real scientific reasons behind this unexpected surge in brightness, and what it might mean for December 2025, when 3IATLAS becomes visible to millions of people right here on Earth. And you'll want to stay with me until the very end, because the final part of this story will definitely surprise you. Before we dive into the mystery of its brightening, we first need to understand what 3IATLAS actually is. This object is only the third confirmed interstellar visitor to ever pass through our solar system. The first was the strange, pancake-shaped object Oumuamua back in 2017, which didn't behave like a normal comet at all. The second was C-2019 Borisov, which was a more traditional-looking comet just from another star system. And now we have our third visitor, 3IATLAS, discovered by the Atlas survey. So what makes this object so special? Well, for starters, it's moving way too fast to have come from our own solar system. Its orbit is hyperbolic, which is a fancy way of saying it came from the vast emptiness of deep interstellar space, and after its visit, it will never return. Its composition doesn't quite match the comets that were formed around our Sun. And most importantly, it's getting brighter far more rapidly than any of the scientific models predicted. This unusual brightening is what captured the attention of astronomers all around the world. And believe me, the story is only getting stranger. To understand the mystery, we need to cover the basics. A normal comet brightens as it gets closer to the Sun. This makes sense, right? Sunlight heats up the comet's surface. This heat turns the ice directly into gas, a process called sublimation, which releases powerful jets of gas and dust that reflect sunlight. This is what makes the comet appear brighter in our telescopes, especially in the weeks right before it makes its closest approach to the Sun. So yes, brightening is completely normal for a comet, but 3ITLAS is different. Here's why. First, the brightening is happening way too fast. The rate of increase just doesn't match what we'd expect from typical solar heating. Second, the pattern is irregular. Instead of a smooth, steady rise in brightness, it's jumping in sudden, unpredictable bursts and flares. Third, the timing is unusual. 31ATLAS started getting brighter while it was still deep in the Sun's glare, a time when it really shouldn't have been this active yet. And finally, it brightened far more than the models predicted. Astronomers use sophisticated models to estimate how bright comets should get. 31 Atlas blew past those expectations. By a lot, and this is where the real mystery begins. The most scientifically accepted explanation for this is something called thermal stress fracturing. Here is how that works. When a comet travels through the freezing vacuum of interstellar space for millions of years, its surface becomes incredibly cold. Parts of its crust can reach temperatures near absolute zero. Now imagine that frozen surface is suddenly exposed to the warmth of sunlight for the first time in eons. The result? The ice expands. The rock contracts. The surface cracks violently. These new cracks can expose fresh layers of ice buried underneath, which then instantly vaporize, releasing huge jets of gas and dust into space. This process creates a chain reaction. Sunlight hits the comet, the surface cracks open, the subsurface ice erupts, and the comet's brightness suddenly spikes. The new dust cloud expands and the comet looks much brighter from our vantage point on Earth. This theory perfectly fits some of the patterns astronomers observed in 3IATLAS. The sudden brightening, the short bursts, the irregular light curves, and the large releases of dust. But this explanation isn't the whole story. Because some scientists notice behavior that just doesn't quite match typical thermal cracking. This is where we have to explore the more puzzling possibilities. Unlike the comets in our solar system, 31 Atlas wasn't born around our Sun. It was formed in the icy, outer region of a completely different star system, possibly one with different chemistry, different temperatures, and different environmental conditions. This means it could contain materials that aren't common in our neighborhood comets. Scientists suspect it might contain exotic ices, like solid carbon monoxide, carbon dioxide, nitrogen ice, ammonia ice, or even methane frost. These types of ices vaporize at much lower temperatures than regular water ice. So 3I Atlas might be brightening faster simply because these exotic ices are vaporizing earlier, causing a faster brightening. Even weak sunlight far from the sun could be enough to trigger a massive release of gas. This would make the cloud of gas and dust around the comet, known as the coma, much larger, which gives it more surface area to reflect light. It's also possible a chemical chain reaction is happening. Each burst of gas exposes deeper layers of these exotic ices, which then causes the next burst, and the next. This could explain the sudden dramatic spikes in brightness we've been seeing, but there's another theory. Some astronomers believe 3I Atlas might actually be fragmenting, or breaking apart. Comets often split when the thermal stress becomes too strong, when pockets of ice explode from within, or when the nucleus starts spinning too fast. The gravitational pull from planets can also distort their structure and tear them apart. When a comet breaks apart, it dramatically increases the total surface area exposed to the sun, which can cause a rapid brightening, a sudden release of dust, and chaotic variations in its light. If 3I Atlas is shedding pieces of itself, it might explain the unusual brightness curves. And is there any evidence for this? Well, there are some hints: its rapid rotation, its apparent structural instability, and the irregular light emissions. And here's something really interesting. Borisov, the previous interstellar comet, also showed signs of breaking apart. Could this be a common pattern among interstellar visitors? It's possible. Another explanation involves the solar wind, that constant stream of charged particles flowing out from the sun. Most of our solar system's comets are familiar with the solar wind's behavior, but 3I Atlas might not be. If the comet has a large amount of ionized gases trapped beneath its surface, the solar wind could trigger magnetic disturbances, sudden charging events, and light flares. This process can increase a comet's brightness dramatically, especially when it's hidden in the sun's glare, which is exactly when 3I Atlas began to brighten. It's a rare phenomenon, but it's not impossible. Astronomers rarely use the word unknown publicly, but with 3I Atlas, they're using it more and more often. Why? Because the comet's light curve, the graph of its brightness over time, doesn't perfectly match any single model. Not solar heating, not typical venting, not dust release, not fragmentation, and not even the exotic ice models. There are still unexplained anomalies. The exact timing of the brightening, the sheer intensity of the spike, the strange asymmetry in its coma, the unusual color shifts, and the rapid fluctuations in its light. We see patterns that match known physics, but we don't have a single perfect explanation that ties it all together. This is why 3I is one of the most closely watched interstellar objects ever recorded. And the real mystery is still unfolding. Now for the most exciting part. 31ATLAS is currently moving into the perfect position for us to observe it from Earth. Very soon, it will emerge from the sun's glare. Its brightening will become much clearer and easier to study. Ground-based telescopes will finally get a proper, unobstructed view, and amateur astronomers all over the world will begin tracking it. We'll finally start to understand whether it's a stable object or if it's in the process of breaking apart right before our eyes. So what are the predictions? Well, if the brightening trend continues, it may brighten enough to be seen with a good pair of binoculars, becoming a popular celestial target this December. It could also surprise us with another flare, as thermal processes might cause another massive burst of brightness. There's also the chance it might fragment completely. If it breaks apart, its brightness will spike dramatically and then quickly collapse as it fades away. Or it might just settle down and behave like a normal comet from now on. Maybe those early irregularities were just one-time events. The truth is, nobody knows. And that's what makes this story so compelling. This isn't just another comet. 31ATLAS is a messenger from another star system. Studying it could help us answer some of the biggest questions in astronomy. What do other solar systems look like? What kinds of materials form in the vastness of deep interstellar space? Do other systems produce comets like ours? How common are these exotic ices? Are interstellar objects fragile, or are they stable? And what can these visitors teach us about our own cosmic origins? We rarely get a chance to observe something this ancient, this distant, and this mysterious up close. Every spike in its brightness tells a story about where it came from, and what it has endured on its incredible journey. And as it approaches its closest point to the sun, we are finally getting to read that story. 31ATLAS is brightening faster than we expected, and faster than any model predicted. But whether this is caused by thermal cracking, exotic ices, fragmentation, the solar wind, or something we haven't even discovered yet, one thing is absolutely certain: the next few weeks are going to reveal the truth. So stay curious. Keep watching the sky. And keep following this journey, because the story of 3IATLAS is just getting started. Subscribe to the channel and turn on notifications so you don't miss our next update. We'll be sharing visibility dates, new telescope images, and the moment this incredible comet finally becomes visible from Earth. Thanks for watching.